Today we're going to explore all the different places and ways that Python is used in Houdini. To start, let's go to the technical desktop because that has a Python shell at the bottom. Quick note, on my version of Houdini, which is 18.5 build 532, it's using Python version 3.7. If you have an earlier build or an older version of Houdini, it might be using Python 2.7. That's okay. Today we're more focused on how and where Python is used rather than the specific version. Next, I'd like us to set the default expression scripting language to be Python. The way you do that is come up to the Edit menu, select Preferences, and go over to Scripting. And at the top, it lets you know what Houdini is using when you write an expression. You have two choices, HScript, the older scripting language, and Python. You'll want to make sure that Python is selected. And let's go ahead and accept that. So what does that mean when you select Python as the default expression language? Let me show you. Let's say we add a sphere to our project. Now, over here in the network view, if you select a node, underneath it, it displays all the parameters that you can use to control that node. Here is a gear icon that allows you to go through and work with a parameter interface. But to the right of that is the Python icon. That lets you know that any expressions you want to write to change these parameters, you need to write using Python. And if you click on this, you can see there are the same two choices, HScript and Python. So if you see an H here, you'll want to double check that you correctly set Python to be your expression language. But you should see a Python icon right here. Now, while we're here, I want to demonstrate one of the most common ways you will use Python inside Houdini. For every node, it doesn't even have to be a geometry node. Like, let's go ahead and create a camera node. And let's also add a light. I will add a spotlight. There. Now if we pop out, you can see we have a sphere, we have a light, and where is the camera? I think the camera is probably at the origin. Yeah, let's move that out here so we can see all three objects that we have in our scene so far. Any of these nodes has a parameter interface, and each of the parameter interfaces, like for the spotlight, that's interesting. I don't understand why the spotlight has defaulted to HScript, but let's select Python. What about camera? Okay, the camera node is selected to Python. I'm curious about that. I might look to see if there's any other nodes that maybe accidentally default to HScript, but that's something to be aware of. Is I've seen that, for example, in working with tops and lops, is I'll create a node, and for whatever reason, even though Python is my default expression language, I'll see the HScript icon here. So that's just something you want to look out for. Now let's return to parameter expressions. So we have a geometry node, a camera, and a light. All of them have different parameters to control how those nodes work. And you can use Python to dynamically change these parameters. You can actually use Python to simply compute the value, but you can also, if you especially want to animate or change the value of these parameters over time, Python expressions are a great way to do that. Let's do a quick demo with the sphere. Now there's several different ways you can move geometry around inside Houdini. One is to set up a simulation, and Houdini's solvers will calculate the collisions and the forces and move the thing around for you. You can also use keyframes, but now what we're going to do is we're just going to use simple Python expressions. So we have this sphere. Let's rotate it around into the default position. And what I'd like to do is just move the sphere along one direction and have it kind of rotating. So it'll be kind of moving in a helical path. So we are going to come down to the translate parameter. And for the x value, let's just move it at a speed of 2 meters per second times time. And here we will use sine of 5 times time. And this z value will be cosine of 5 times time. Now, if we play this, it will move way too quickly because we need to set the real-time toggle to be on. Now, if we play this back, let's see. Okay, so you can see it's moving away from us here in the x direction in a circular motion. There we go. And you can see as it slowly moves out of the path of the light, it goes into shadow. So that's one way you'll use Python in Houdini, is to write little parameter expressions. Next is the Python shell. The Python shell looks like a standard Python shell outside of Houdini, but it's a little bit different. And one way you can tell that it's different is here. It lets you know what version of Houdini you're using and that the HOU module has already been imported. So let me go and make this a little bit taller. If you call the dir function, it lets you know what's available to you. And Houdini has already imported a few Houdini-specific modules, the most important being HOU, the Houdini module. So inside the Python shell, you can write little bits of Python code that can change any node you have in your project. You can also even change the user interface. This actually gives you a Python command center for controlling Houdini. Now, you don't have to be in the technical desktop to work with a Python shell. So let me go ahead and minimize this. Let's say we were in the modeling desktop. You can come up any place to where you have a pane tab, and you can add a Python shell to that. Now, when I added this Python shell, you notice you don't see kind of like the cursor. The way you get that is just click in the window and hit return, and you're now in the interactive mode. So if we type in the dir function, you can see the same packages. The HOU module is there for us to use. I want to show you something interesting, by the way. Let's say we set x to be 12. Type in dir. You can now see x has been added, and its value is 12. Let's say you were to switch back to the technical desktop and bring back the Python shell here. Type in dir, you can see x is available to this shell as well, and x has a value of 12. So that's something to keep in mind. As you switch around from different desktops, you can bring up a Python shell and they will all share the same functions and variables that you use. There's another way to create, let's switch back to the modeling desktop here. There's another way you can bring up a Python shell. You can add it here, which we just did, but if you come up here and to the Windows menu and select Python shell, what it will do is it will give you a pop-up Python shell. You don't see the symbols waiting for you to enter a Python command. The way you get that is just click into the Python shell window, hit return, and there you go. You're good to go. And by the way, x is still 12. It's still available here. And if you want, you can define a function. So like you could make a test function where it has an input, and what it just returns is, let's say, the square of that number. So test of 5 should be 25, and it is. Now let's close the shell, come back over here, and let's try test of 7, which should be 49, and it is. So that's another way to bring up a Python shell, is through the toolbar. By the way, it has a keyboard shortcut. A good thing to remember, Alt-Shift-P, P for Python. So if you press Alt-Shift-P, you'll get that pop-up again. And notice it keeps the same state as we had earlier. So if you were to switch to a different desktop, Alt-Shift-P, there you go. It's always at your fingertips. So that's another place you will see Python, is in the form of a Python shell that gives you the ability to control Houdini using Python code. Another place that might be a little hidden to you and is if you come up to any of these toolbars, you have a lot of different tools. Let's look at, let's say, the Torus tool. If you right-click, there's an option to Edit Tool. If you click that, it gives you the path to the original tool, and it also gives you a path to, if you make any changes to this tool, where those changes will be saved, because you don't want to overwrite the way Houdini ships with these tools, but they do want to give you the ability to customize them. Now, look at these 5 tabs here. One of them is Script. If you click on Script, what it displays is the Python code that executes when you click on the Torus button. And this is a good way to also learn how to use the Houdini Python functions and modules and classes. For example, if you come to a box, right-click, select Edit Tool, you can see what the bounding box will be by default and what the division rate is of the mesh. I want to show you how you can actually change this. Earlier we made a sphere. If you click into this and select the sphere node, you can see that the radius is 0.5 and it has 13 and 24 rows in the mesh. Let's get a little closer so you can see that. Let's say we wanted to change the default. Let's say we wanted the default radius to be 1, and let's say the rows and columns to be 50 each because we'd like a finer mesh by default. To make this change, come up to the sphere tool, right click and edit tool, and you can see the radius is set to 0.5. Let's change that to 1.0. And this I find interesting. I don't see where the rows and columns are set to 13 and 24 by default. So that might inherit from something else. So we're not going to worry about that right now. But also 1.0 is a deceptively round number. Let's change it to 1.732. That's the square root of 3. And that way when we make a sphere, it'll be very clear that the value we entered here for the radius is the value of the radius being used. Let's click accept. Let's go up a level. Let's hide the Python shell, give us a little more room, and let's add a sphere. We'll add a second sphere over here. So if we come into this second sphere and look, you can see the radius is 1.732. By the way, the reason this looks different than that is the lighting. So I'm just going to zoom out a little bit, take our spotlight, and move it out. There you go. You can see the first sphere, the default radius was 0.5. The new one was 1.732. Before we continue, let's go back and return the sphere tool to its original form. I'm just going to right-click, Edit Tool, come over to the radius, and select 0.5. Let's accept that, and it's now back to the default value. Another place you'll encounter Python and Houdini is when you want to make specific variables and functions for a particular project and you want to save that Python code. Right now, if you were to look at the Python shell, we defined a value for x and we defined a function test. Test, remember, just squares a number. So if right now, if we were to close Houdini and open it back up, these would no longer be there. And why don't I prove that? Let me close this version of Houdini and let me reopen it. Okay, if we come back to the Python shell, x has not been defined and test has not been defined either. So what do you do if you're working on a project and you want a few variables to persist? You want to be able to save your project, come back later, and know those variables are going to be there. For that, you want to write session Python code. Here's how you do it. Come up to Windows and select Python Source Editor. At the top, you can see it says hou.session module. That means everything you write here is going to go inside the session module, and when you save your project and reopen it, it will still be available to you. For example, let's say you're doing a simulation, a simple simulation, and you want to specify the speed of something, and you want your speed to be 2.7 meters per second. Let's go ahead and accept that, and let's see if that's available in the Python shell. Speed, not defined. Why is that? If you type in dir and look at what's available, we have the Houdini module, interpreter, node themes. Notice the session is not available in the Python shell by default. However, let's create a sphere, Control-click, put it at the origin, and let's see if speed is available here. Let's say we want to just translate and move this sphere along the x-axis. Let's type in speed times time. Notice speed is not a function, so there's no parentheses required. If we hit play, it moves. That's interesting. Let me do real time. Let's toggle real time. So what this shows is that when you're writing expressions, any values that you created in the Python source editor, which is in the session module, is available to you. But in the Python shell, by default, it is not available to you, but you can get it. If you type in hou.session, you're now in the session module, and notice what is available in the pop-up. speed, and it's 2.7. So when you can use all your session functions and variables inside a Python shell, you just have to remember that they live inside the session module. So why is it that the expressions and the Python shell have available to different things? Let me show you one other thing. Let's say we want to take the sine of 5. We get an error. It says sine is not defined. What if we wanted the y value of this sphere to be the sine of 5? If you click on translate, it toggles between the current value and the expression. It evaluates just fine. So the expression has available to it the variables and functions defined in the session module, and it also has available to it even certain math functions which aren't available to the Python shell. To better understand this, let's go to the SideFX website. Under support, go down to documentation and click the version of Houdini you're using. I'm using 18.5. Scroll down to reference and click on Python scripting. If we scroll down, it gives you a nice overview of all the different places Python is used throughout Houdini. So let's look at parameter expressions. If you click on that and scroll down, there's a very important thing. It lets you know that for Python expressions, by default, you have available to everything from the Houdini module, everything from the session module, and also the following math functions, which are really common. So you have the trig functions, the inverse trig functions, floor, log, exponential powers, and you have access to the functions for converting back and forth between degrees and radians. So the Python expressions give more to you by default than the Python shell, and you'll want to keep that in mind. Next, I want to show you that there are even specific nodes dedicated to Python. If you come over and you are in the object folder, you're in the object context, select tab, start typing Python. You can see there is a node called Python script. This allows you to type in a little Python snippet to do some work, and you can even wire it together with the geometry and things like that. And another place where Python is heavily used is in the top networks or task operators. If you come over and click on tasks, there's always a default top network created for you. Now let's go full screen here. If you select tab, there's a lot of pipeline specific and work specific nodes available for you. Notice that there is a menu specifically called Python, and they give you 5 unusual looking Python nodes: mapper, partitioner, processor, scripting, and scheduling. These are, if you're working on a pipeline team or you're building a pipeline where you want to be able to go through and do a lot of parallel processing of a lot of individual frames and things like that, that's what tops are great for. And by default, they have a lot of Python utilities available to you. And in fact, if you start typing in Python, those aren't the only ones. For example, there's a Python command chain or Python server begin. Those aren't here. So the Python is used extensively when you're working with tops and pipeline work. Let's return to the object context, since that's where we spend most of our time. Now, one last thing before we wrap up is I'd like to return to the SideFX help documentation. Let's go back to the Python scripting page. You'll see some references to HOM. HOM is the Houdini object model. Simply put, that's the Python classes and packages and modules and functions that they use to map the Houdini stuff to Python. That's what an object model is. And there's also some great references. One is the HOU module, which is a massive Python module. There's so many different functions and classes here. This is something you'll probably want to have bookmarked. I know I do. And then down here, if you scroll down, there's this section where they talk about Python viewer states and Python viewer handles. What are these? If you come back to Python, when you look at the viewer, the viewport, anytime you select an object, you can see that these little handles come up. if you want to like move it around. Notice we can't move it around because we have expressions for the X and Y, but not the Z. So notice how we can move it in the Z just fine, but we can't move it in the Y or the X direction because those are controlled by expressions. But if we dive inside and select this sphere, notice all the different tools and controls you have here. You have sliders down here that control how fine of a mesh you have. So if you want to specify how many rows and columns there are in this geometry, you can control it there. You can also control it up here. And if you click on Y, it toggles through all the different controls available to you. So there are the ways you can adjust the size of it in X, Y, and Z dimensions if you want to make a more non-spherical shape, ellipsoid shape. Hit Y again and it brings up the rotation tools. Bring up Y again and they disappear if you want to kind of hide those tools. These, and also there's these box controls that allow you to kind of enlarge or shrink in all the various dimensions. And then there's even these planar tools if you want to move your shape around in specific planes. There's the XY plane, YZ and XZ planes. These are view controls. And what you may want to do after a while is when you've been using Houdini a long time, you may find yourself creating custom tools. You can create a custom tool by coming up to the toolbar, right-clicking, and create a new tool. And then just typing in what Python code you want to execute when the person presses that button, and it will create a tool. It will create some geometry for you if you want, or it could even do some work and execute scripts for you. Let's go ahead and delete this. I don't want this empty tool there. But you may also want to go further and not only create your own custom tool, but create viewer interface tools for you to be able to control it. You may want to create sliders here. You may want to have the ability to have these different little arrows do different things to the geometry than simply just, stretch in the X and Y direction. These are what viewer states and viewer controls are for. And in recent versions of Houdini, they give you the ability to go crazy and create and customize to your heart's content. It's really incredible. This shows you how you can handle changes like Python handle events. How do you react if someone grabs a handle and makes some changes? What about state selections? What are the different handles and parameters you can do, and even guide geometry? And that's what these are for. And that's, an entire mini course in and of itself. And we'll explore that a little later, but that's another big, big part of Houdini and Python is you can come up here and create your own tab custom to the type of work that you do. You can create your own tools using Houdini. And then for each tool, you can come in and control and program how you manipulate that thing in the viewport using Python viewer states and viewer handles. So I think that's a nice overview of many of the places you will run across Python inside Houdini, but there's a lot more, and I would really encourage you to come back to the Python scripting part of the help documentation and just click through these and explore. And it's really wonderful that they've switched from HScript to Python, and that with each release of Houdini, they're giving you more and more tools to be able to customize and control Python, not just in the user interface, but you can even write Python scripts without even opening Houdini to go through and do some maybe cleanup or optimizations of your geometries and things like that. So I hope you found this helpful, and I will see you next time.